In this video, we're going to take a look at finding the area between two curves in the case where the curves cross. So let's say we want to find the area between these two curves. Let's call the red curve f of x, and let's call the blue curve here g of x. And let's say that we have bounds of integration that are from this point A to this point B. Well, we can see that within that interval of A to B, that at one point, f of x is above g of x. But within the interval, at this point, let's call this point right here C, at C, they switch. And from C to B, g of x is above a of x. So what we have to do then is create two different areas, A and B, and find the area of those separately. So area A, in this particular case, we would have the integral from A to C, where f of x is above g of x. So we would have f of x minus g of x. And that would be our integral. But area B, which goes from C to B, we have g of x is above f of x. So we would have g of x minus f of x. And so we would compute each of these areas. We would get area A and area B. And then the total area is going to be equal to A plus B. So let's do an example. So we want to find the area of the region bounded by f of x equals 6x and g of x equals x cubed minus 3x from x equals -1 and 2. So here we have the graph from -1 to 2, and make that a little bit smaller. And we can see that from -1 is right here, and 2 is right here. And within that interval from -1 to 2, the graphs switch. We have the curve of g of x is above f of x, from -1 to 0. And then from 0 to 2, we have the f of x is above g of x. So we have two separate areas here. We have area A and then area B. And so again, area A is where the cubic, area A is where the cubic is above the line, which is f of x. So we're going to have x cubed minus 3x is the top curve minus the bottom curve, 6x. And that is going to go from -1 to 0, from -1 to 0. And so we can simplify that a little bit. We have the integral from -1 to 0 of x cubed minus 12x dx. And then finding the antiderivative, we're going to have 1/4 x to the 4th minus 12x squared over 2, evaluated from -1 to 0. And then putting that into Desmos, you're going to end up with 5.75. Now, area B, we're going to have the linear equation above the cubic equation. So we're going to have the integral from 0 to 2, and that's going to be 6x minus x cubed minus 6x. So they're reversed. And simplifying that, you're going to have area B from 0 to 2 is going to be 12x minus x cubed dx. And so that is going to become 12x squared over 2 minus 1/4 x to the 4th, evaluated from 0 to 2. And that will end up being equal to 20. And so the total area is going to be the A plus B. Well, area A was 5.75. That's in the yellow area. And then B was 20, so we're going to have 25.75. And by the way, I made it a little bit messy, but this yellow down here is not really in there. There we go. That looks a little better. All right, so that's the first problem. Problem number 2. Find the area of the region between a x squared minus 2x plus 1 is f of x. And that is an upturning parabola. So f of x is going to be the red curve. And then g of x is the downturning parabola. That's going to be this one. And so we're going from 0 to 3. So our boundaries are from 0 to 3. The lines are very messy. And so you can see that in between 0 to 3, in that interval, they cross. We have, green, we have this area here. And that goes from 0 to 2. I cross at 2. So 2, we're going from 0 to 2 and then to 3. And then from 2 to 3, we have this area. So let's call the first area, area A, and then call this area B. In area A, we're going to have, I said the downturning parabola is going to be the integral from 0 to 2 of 5 minus x squared minus x squared minus 2x plus 1 dx. And so that then comes simplified. Let's see, you're going to have 4 plus 2x minus 2x squared dx. And the area then would become 4x plus 2x squared over 2 minus 2x cubed over 3, evaluated from 0 to 2, which becomes 6.67. Area B, then, which is going from 2 to 3, we're integrating from 2 to 3, is going to be just the opposite. You're going to have x squared minus 2x plus 1, and that's going to have the other one subtracted from it. And then that simplifies to, from 2 to 3, that will simplify to 2x squared minus 2x minus 4 dx. And then integrating that, you're going to have b is equal to 2x cubed over 3, or 2/3 x cubed, minus 2x squared over 2, which would be minus x squared, minus 4x. Evaluated from 2 to 3, and again using Desmos, that looks like it's going to end up being equal to 3.667. And so we have 6.67 and 3.667. And so the total area is going to be the area of A plus B, which is 6.67 plus 3.67, which is going to be 10.34. And there is your area. Third example, example 7 actually. Find the area of the region bounded by the graphs of f of x equals negative, that x squared plus 3x plus 7. That's a downturning parabola. So that's going to be the red one. And then we have g of x is x squared minus 3x plus 3. That is the upturning parabola. That's going to be the blue one. And we're going over the bounds from -2 to 4. So -2 is right here. And so we want the area that's between the two graphs from -2 to 4. And there's my bounds. So where is the area that I'm concerned with? Well, we have this area in here. And then at this point, which appears to be -1, it switches. So this is -1. Here we have -2, and here we have 4. And then between -1 and 4, we have this area. Where the downturning parabola is above the upturning parabola. So they switch at -1. So again, we have two areas, this small yellow area A and the blue area B. So area A is going to be the upturning parabola. And this is from -2 to -1. The upturning parabola, x squared minus 3x plus 3, minus the downturning parabola, -x squared plus 3x plus 11 dx. And so that kind of simplifies to 2x squared minus 6x minus 8 dx. And so then the antiderivative of that would be 2/3 x cubed minus 6x squared over 2 minus 8x, evaluated from -2 to -1. And that'll end up being 5.67. Then area B, well, area B is going to go from -1 to 4, and that's just going to be just the opposite. We're going to be taking negative x squared plus 3x plus 11 and subtracting x squared minus 3x plus 3. And then that is all going to simplify to 8. So we're going to have the integral from -1 to 4 of 8 plus 6x minus 2x squared dx. Kind of running out of room here. The antiderivative of that, let's go up here. So we're going to have 8x plus 6x squared over 2, or 3x squared minus 2 thirds x cubed, evaluated from -1 to 4. And this is area B. And that ends up being equal to 41.67. So we have two areas, A and B. Area B is 41.67, and area A was 5.67. And so our total area is going to be the sum of those two, which looks like it would be 47.34. 47.34. A plus B, 47.34. All right, one more problem. And this one is just going to be a little more complicated. So again, we have two curves, and we have the first one. This one is a downturning parabola. That would be the red curve. And then we have a cubic, which would be the blue curve. And bounds of integration are from -2 to 4. So -2 is right, let's do this in purple. -2 is right here, and 4 is right here. Well, what we have here is three separate areas. We have the area in here, ending at this point, which we're going to have to determine using Desmos. And then we have another area in here, which goes up to this other unknown point right here where the two curves cross, which we'll determine in Desmos. And then we have a third area between the two curves, which is this area all in through here. So we actually have three different areas. So we can call them area A, B, and C. And of course, these are all graphed in Desmos. And Desmos will tell you where these graphs cross. So it turns out that this point right here is -0.813. And this point right here is going to be 2.388. So our first area, area A, is going from, what is it, -2 to -0.813. And that is going to be the cubic equation on top. So we're going to have x cubed minus 5x plus 1 minus the downturning parabola, which is -x squared plus x plus 6. And when you simplify all of that, you end up with x cubed plus x squared minus 6x minus 5 dx. The antiderivative of that would be 1/4 x to the 4th plus 1/3 x cubed minus 6x squared over 2, or minus 3x squared minus 5x, evaluated from -2 to -0.813. And that area ends up being equal to 2.67. Now, area B, let's do that in red. Area B then is going to be the integral from -0.813 to this other point, 2.388. And it's going to be just the opposite. We're going to be taking the negative x squared plus x plus 6 and subtracting the x cubed minus 5x plus 1 from it. So that then becomes negative 0.813 to 2.388. And that is going to end up becoming 5 when we simplify it, plus 6x minus x squared minus x cubed dx. And the antiderivative of that is going to be 5x plus 6x squared divided by 2, or 3x squared, minus 1/3 x cubed minus 1/4 x to the 4th, evaluated from negative 0.813 to 2.388. Heading on over into Desmos, plugging in the antiderivative and evaluating it, we end up with 18.39. All right, and then we've got third area. Let me do that over on this side so we can kind of keep the drawing in here. And the third area is just like the first area. Area C, we're going to have the integral from 2.388 to 4, and it's going to be the cubic on top again. So we can go back to what we did over here with area A. It's going to be exactly the same as this. So I'm going to just rewrite this now, x cubed plus x squared So this is going to be x cubed plus x squared minus 6x minus 5 dx. And of course, the antiderivative is going to be the exact same too. So area C's antiderivative is 1/4 x to the 4th plus 1/3 x cubed minus 3x squared minus 5x from 2.388 to 4. So you already had that antiderivative over here. You had this antiderivative in Desmos. You can simply use the same antiderivative again and just evaluate it at the different endpoints. So when you do that, you will end up with C, area C, being equal to 33.71. So the total area is A plus B plus C, which is 2.67 plus the 18.39 plus the 33.71. And so the total area is going to be equal to 54.77. All right, and that is area between two curves.